Thanks everyone for having me. I'm Nelson. I work at ZenJob, and I'll be giving a talk on migrating your build.gradle files to Kotlin. First off, I wanted to thank Konstantin for explaining DSLs, because that will definitely, well, that explains half my talk basically, so it makes it a lot easier to understand how the DSL works and interacts with Groovy. I've been using Kotlin for about 2 years now. I started working with Kotlin at my previous company, and we've been migrating some of our code to Kotlin at ZenJob, and our code base is now about 30% Kotlin. So anyways, this talk is going to be about some pros of migrating your build script as well as the cons. I'm going to go through some examples, some specific examples of migrations, and I'll talk also a little bit about how it works under the hood. This talk is all about migrating from build.gradle to build.gradle.kts. Some motivations on why we did this. Since our code base was migrating into Kotlin for production code, we thought it'd be nice that our build scripts are also in Kotlin, so that way we don't have to learn Groovy. Groovy syntax is weird. People don't like Groovy. So yeah. I will say though that the Kotlin DSL for Gradle is at version 0.15.6 right now. So it's not a production release. It's still very much a beta, and I'll talk about that in some future slides. Some other motivations were to experiment around with this new DSL. And so really this was kind of an experiment we did at ZenJob to understand how it works and some pros and cons. Here's just my short little pro and con list. As you can see, the con list is a little bit longer, and I'll dig into more of these things. And here by, yeah, I'll explain these in the next slides. So the first thing is when you migrate your build scripts to Kotlin, you get type safety. And with type safety comes IntelliJ's parameter hints. So in your build scripts, you can see the type of the object. And this makes it, in my opinion, a little bit easier to understand. With type safety also comes compile time safety. So if you have a line of Groovy code like this, where foo is nothing, it doesn't do anything, this will actually run in Groovy if on your local machine, but then on CI it'll fail because foo is not a thing you've defined. But if you migrate your build script to Kotlin, this will not compile. Apologies for the colors. So that's kind of one nice thing that comes along with type safety. Another nice thing is autocomplete. The Groovy build scripts have pretty good autocomplete. It's a little bit nicer in Kotlin because you have stronger type safety. And here's just a little example in the build scan autocomplete. Sometimes though in Groovy scripts you don't know the type and then you don't get autocomplete, so that's where the type safety comes in handy. So on the cons list, you definitely get slower builds. On this next slide, this is just compiling our build scripts. So if you're using build.gradle files, there's no compilation time, or none that you can notice. But if you migrate your build scripts to build.gradle.kts, you can have some pretty slow compile time. So just for a reference, I checked this right before the talk, and this file that takes 2.5 seconds to compile is 285 lines. So that means each line takes 1/100th of a second to compile, and that's really slow. Another thing is that your build.gradle scripts do not compile in parallel. So you actually have to wait 2.5 seconds before this one can compile, and then 1.5 seconds before this one can compile, and on and on and on. So as you start to modularize your build, you can actually get really, really slow builds. I filed a bug about this because if people want to actually be able to use this, this is kind of a big problem. So if you go on the Gradle Kotlin DSL, yeah. So, but this is a good lesson. If you're experimenting with new tools, you should file bugs because it helps improve those tools. Another thing we ran into is that there's less documentation. So the best documentation there was these samples in the Gradle Kotlin DSL. And I'll have this link at the end of my slides in case you want to copy it. But if you just Google Kotlin DSL, it's the first thing that comes up. There's some really good samples in there, everything from multi-projects to tasks. And you can just dig through and find, you can usually find for most basic things an example in there that's about the same. Another con is you're going to have to dig into the source to figure out how plugins are implemented if you want to use specific plugins in the Kotlin syntax, because a lot of plugins are built with the knowledge that they're going to be used from the Groovy language. You have to look at the implementations of plugins in order to figure out how to connect their APIs with Kotlin. Sounds a little complicated. I'll get into that a little bit later. So anyways, this is just the list of pros and cons again. So the next part of the talk, we're going to go into examples. And so we'll start with simpler examples and get into more complex examples. And then a little bit of how it works under the hood. I have even more complex examples from our code base. So if you ask questions at the end, I can dig into those, but some of the slides are after the end of my talk, just because this is a short talk. So the first file you can really easily migrate is your settings.gradle.kts. This is your file where you tell Gradle where all your modules are. And for example, this might be a very simple version of a settings.gradle file. And to migrate it to Kotlin, it's super easy. You just remove all the includes, and it's actually shorter and nicer. And you have type safety, and you can actually command click into include and look at the source, which is not something you can do in the build.gradle version. So next, I'm going to take a look at migrating a build.gradle file in a very simple module. So we'll start with the plugins block. So if you have a very simple build.gradle file that looks like this, and this is not an actual build.gradle file because you would never actually apply the Java library and the Android library plugin, but this is just to show how different plugins are used in build.gradle. Okay, so if we focus on the plugins block, we have 3 plugins, and they're actually, all 3 of them are migrated in slightly different ways to Kotlin. And I'll get into why that is on the next slide. But one thing I found is that the Kotlin DSL is slightly inconsistent in the way it exposes APIs to Groovy. One reason here is that you can't have a dash in Kotlin as a method. So unless you put these backticks in it, but in Groovy it's perfectly allowed. So that's one reason. So yeah, zooming back on the build.gradle file, that's what it looks like in Kotlin. I'll get into the rest of the migrations later, don't worry. So yeah, if we focus in on this plugins block, specifically on the Kotlin part of it, so this is actually a function because we're passing it a parameter. And you can command click into it and look at the source. And if you look at the source of it, well, it actually is pretty much the same as ID, but they wanted to save you a bunch of time figuring out what the ID was, because the Groovy version is so easy to use. So this is just an extension function that you call on the plugin dependencies spec, which is that outer block in the previous slide. and it just calls this ID. And how this is generated is actually with some very simple code generation under the hood. And there's just this string in generate Kotlin dependency extensions.kt in the Kotlin DSL. And it's passed the embedded Kotlin version for the documentation. And this string just turns into some code. So this is like the very most basic version of code generation you can do. And it's generated with this task called generate Kotlin dependency extensions. And this is a build.gradle task in Kotlin. So I didn't want to get into too much of tasks and how they're written, but this is just an example of how that code generation works under the hood. Okay, so next up is the Java library. How does that work under the hood? Well, it actually works almost the same way as the Kotlin one. It's also an extension function, and it's in this built-in plugin extensions.kt. But if you look at the source of the Kotlin DSL, you won't find built-in plugin extensions.kt because it's also generated. And the way it's generated is with this function where it basically is passed all the different Gradle jars for all the different plugins that come built into Gradle. And for each one of them, it generates this this extension function. And they all have a different, they're basically all org.gradle.something, and then it generates a nice little name, so it makes it a lot easier to use all the plugins in Kotlin. All right, so going back to our simple little build.gradle file, next we're going to focus on the dependencies block. So if we have a very simple dependency block that looks like this, where we pass it a string, the Kotlin version looks like this. Basically, you just add some quotes and some parentheses. Very simple. And then this. Yeah, magic move always crashes Keynote. Fun fact. Okay, I think we were right here. Yeah, so that is what our file looks like in Kotlin. I'm going to go back to the Groovy version just so you can see the difference. Here's the Kotlin version. It looks pretty similar. All right, so a lot of you might have your dependencies in ext blocks. So how do you migrate that to Groovy or to Kotlin? So let's say you have a simple ext block that looks like this. You have a simple dependency here, and then you also have a map of dependencies inside a block, which is a pretty common pattern you see for grouping your dependencies in the ext block. And then the Groovy version looks like this. So you have nested access to the support.annotations, and then just regular dot access to things that aren't nested. Yeah. So how does this work from Kotlin? Let's just focus on the simple version first in the ext block. The Kotlin version looks like this, pretty much the same thing. Well, almost. So the thing is, we had to write an extension function. So there are some built-in extension functions, and you can obviously write your own, and you can shape the DSL exactly how you want it to be. So what this does is it goes into the root project. The root project is where I define my extension block, and it uses the get operator on the extension map, and pulls it out and casts it to a map of any type. Fun fact, everything in Groovy is either a string or a map. And calls that map with the key you just passed it, and make sure it's not null, and crashes if it's null, because Kotlin obviously has type safety, Groovy does not. And this function returns any. Now, this is just the extension function I defined. The reason I returned any is because I can either have a string here, which I pass to test implementation, or I can have a map in the case of my nested ext block. So yeah, that's the extension function I wrote. Obviously, there might be some other better versions of it, but it allows you to pretty easily access things from your ext block. Yeah, so for the nested access, it's a little bit hacky, but it'll do. But basically, I cast that any as a map, and then since it's a map, I can just use the get extension, operator extension in Kotlin, and then cast that to a string. Cool. So this is the whole build.gradle file again, and then the last part is, of course, the target compatibility part of that. This migration is pretty simple. Instead of this, you just have to put it inside that closure thingy. But you might ask, how did I know I had to put it inside that closure thingy? If you ask, I can dig into those details, but it's actually kind of tricky. So next, I'll focus on another common pattern you might see in your build.gradle files. You might have some specific logic that you only run on CI builds. So the way you set a value on the ext block very simply in Groovy is like this. The way you set it in Kotlin is like this. So this is what the difference looks like. And then the thing is, it's a little tricky to get this value in Kotlin, whereas in Groovy you can just write is CI anywhere in your build script, and you have this Boolean. In Kotlin, you have to write an extension function, and this is slightly different than the extension function I told you before, or to access the extra block. So there's many ways of doing things. This is just an example. So yeah, this is how you would use the Groovy version of it in Groovy code, and this is how you would use the Kotlin version of it in Kotlin code. So that's basically the difference, except in Kotlin you also needed to write the extension function. So that comes to the end of my talk. In the end, it was a fun experiment. Build speeds are definitely slower, and the Kotlin DSL is definitely still in a pre-release. You can also learn how everything is an extension function, and that's how you shape DSLs. So yeah, and if you have any questions, I can happily dig into more samples. This is the link to the samples from the official Kotlin DSL samples, and thank you very much.
Thank you, Nathan. Questions? Question time. Oh, Tassin.
Hey, thanks for the talk. I know that Android team for the Android plugin tries to make the public API Java only so that it is easy to use with Kotlin as well. But like in complex build files, you may interact with other plugins or the official Gradle API that is not converted to Java or Kotlin yet. So like basically Groovy, where you don't have the type safety. So how do you interact with that? Because if you convert the whole thing to Kotlin, did you have this kind of challenge where you have difficulties accessing some Groovy methods or declarations?
Yeah. So I guess, yeah, there's always like tricky examples. A lot of time I had to dig into the source to figure out how it was implemented. So I can give a quick example, which is actually my next slide, which is this example of the source compatibility. You have to have this extra little block out here, and the reason for that is that I literally just dug through all the source to find where you have this set source compatibility function, and that's in this file called Java plugin convention. Sorry, I didn't really rehearse these slides, but these setters turn into synthetic property accessors in Kotlin, and that's how you access it like this. But Java plugin convention is not something I applied anywhere to my project, but it's actually applied in the default Java plugin, like so. And so whenever the Java plugin is applied, it applies this Java plugin convention to your project. So in Groovy, you can just access all the things that this Java plugin convention has, like those methods I just saw. But in Kotlin, you don't know about it because it's not part of the Java plugin. And so luckily, there's this org.gradle.kotlin.dsl.accessors, and this is also another generated file, and it comes with a lot of convenience methods to access Kotlin things. Man, you asked a really good question, because I have slides for it. So basically, that Java block that you saw before uses this this function here, which calls configure with this extension function. So this is a, what is it called? Thing with receiver, that Kotlin thing. I'm really bad at naming things. But anyways, it calls convention.getPlugin by name and with Java as an argument. And so basically, like, you can write it three ways. This is like the simple way I showed it to you. You can also call it with convention, Java plugin convention, and you can also just cast this to has convention and call convention.getPlugin, blah, blah, blah. So yeah, you have to dig through the sources sometimes to figure stuff out. Another, okay, no. If someone asks another question on Groovy, I have another slide on how to interact with Groovy, but yeah.
Next question. Flo.
So what's the final conclusion of this experiment? Are you guys going to keep using this in production? Are you using this in production? Are you going to revert to Groovy? Like, what's the?
Yeah. So yeah, we're using it in production. I guess we haven't really decided if we're going to migrate back, but migrating back is a bunch of work, so probably not. I will say the 10-second compile time is only once. Or 20 seconds, you only have to do that once, and then you have to do it again every time your build scripts change. So what we did was, instead of using the ext block, we have all our dependencies defined in the build source. The problem with using build source is that anytime your build source changes, you have to recompile all your build scripts. And so that's when you get that 20-second cost, but it's only once, and that's it, every time you change your files. So it's not like every single build is 20 seconds longer. So the final conclusion is, I don't know, do it at your own risk. I wouldn't recommend it for everybody, especially large projects. You're definitely going to take a hit. But if it's a small project and you like Kotlin, Kotlin's fun. Writing extension functions is fun. So yeah, try it out.
More questions, I see.
Thanks for the talk. When I have a big multi-module project with a bunch of Gradle files, I just heard between the lines that it's probably possible to just convert some
to KTS files, but how well is he interop with good old Gradle files and KTS files?
Yeah, so that's a good question. The way to approach the migration is definitely to do it incrementally. You can start with your settings.gradle like we did, because that's the simplest one, and just migrate that. And you can definitely just migrate one build file at a time. And then you can just write extension functions in order to have the same API between the Kotlin files as the Gradle files. In the end, we just migrated the simplest files and then got to the bigger ones. In the end, our root build.gradle file was like the meatiest one, and it had all sorts of crazy things going on in there. But the thing is, the interop was actually very easy and almost never a problem. Accessing the ext block was maybe the trickiest one, but for pretty much everything else, there's already an extension function written. You just have to write your own for the ext block, and that depends on how you structure it. Yeah. Good question.
Cool. More questions. The last question on this party.
Hey, great talk. A question about extension functions. So do you have any way to distribute this between different Gradle projects? So meaning that they have a bunch of microservices and they want to have a common library of these helper functions like ECI. Is it any official way of doing that?
Yeah, that's a great question. So you can put it in your build source. So what I mean by build source is if you just create a directory called build.src in your project, and then in there, it's basically like another level of build. So the build source is the source for all your build scripts. And in there, you can write any sorts of files you want. And so you can put all your extension functions in those, and then it'll be available to all your build scripts. Now, once you start doing build.src, every time you make a change to build.src, it invalidates all your caches, like I mentioned earlier. Another caveat we ran into with the build.src is that we ran into this bug in Kotlin that we ran into often on CI, where it was like trying to unmarshal headers for incremental builds or something. And on CI, it would just, every like 10 builds or so, it would just crash. And then they fixed this issue in Kotlin 1.2.21 or 1.2.20, but then we still ran into it. And like digging around, I was really confused because nobody else was reporting that they were still having problems with it. But it turns out the build source was using an older version of Kotlin. So that's just another thing to be aware of. Make sure your build source and the rest of your project are using the same version of Kotlin. But yeah, hope that answers your question.
Thank you, Nelson.
Thanks, everyone.